Okay, here we're dealing with hazardous communication, or HAZCOM, as we like to call it in the industry. It's about the health hazards in the industry and occupational safety in general, and of course here we're focusing more on construction. So it's all about how to handle dangerous chemicals and substances, how to clean them up when they get spilled, what to do and what not to do in various circumstances. And where do you get this information from? So the first thing I would say is, yes, we're going to be focusing on the safety data sheets, the SDS, for each substance at some level, where we'll just look at some samples. But in general, you can find places that deal with hazardous substances, hazardous materials, toxics, and things that are chronically dangerous in some fashion in various places. But the main place is 1910-1200, the third bullet down, where it says it's considered the hazardous communication standard itself, or sometimes called the worker right to know standard, because ultimately every worker has a right to know how to handle the dangerous materials that they are dealing with. And so they need training, they need information. And that's part of what a safety data sheet does, is it gives you the official information on that particular chemical or substance. There's other sections in here, but that's the main area. 1910-1200 is a general industry standard, not a construction standard. Okay, let's see. So when you're unsure about something, you often keep your mouth shut. I don't mean you personally, but we in general. This can often be hazardous because you need to have the correct information. It's important in occupational safety that everyone has all the right information. And employers are good at not sharing information. They tend to keep things close to the chest, sometimes like a card game, and that doesn't work well in safety. However, in this picture, when everyone else is unsure about the situation, sometimes it's wise to keep your mouth shut, like the fox in the middle here. Okay, so it's kind of the opposite. So, hazardous communication, or HAZCOM standard, again called the Worker Right to Know program, employers have an obligation, a responsibility to educate workers about the hazardous materials that they can end up using on the job. All materials must have a proper label. Every material must have a proper label on it, and you must have a safety data sheet on file. The SDS, or the safety data sheet, includes information such as the properties of each chemical, like the physical and health and environmental health hazards, protective measures about how you protect yourself, that means personal protective equipment, and techniques of how you deal with spills, fires, contact, and that sort of thing, and first aid measures and that sort of thing. There are safety precautions for the handling, storage, and transportation of the chemical. Now, there is a course called HAZWOPER, which sounds like a dangerous hamburger, but it stands for Hazardous Waste Operations and Emergency Response. So it's a big old acronym, a big old abbreviation. The 40-hour HAZWOPER course earns you a HAZWOPER credential, the full 40-hour HAZWOPER credential, that once you start taking that course, in order to keep it active, you've got to take an 8-hour refresher course every year. So you kind of want to, some ways, wait until you really are sure you're ready to keep renewing this thing. It also means that wherever you get the HAZWOPER course, you want to make sure you get it at a place that does offer the 8-hour refresher, because you're supposed to go back to the same people every time for your refresher. Anyways, this course delves into HAZCOM deeply, so it's a great overall course for understanding the chemistry. Yes, it's designed for people who are cleaning up hazardous waste, but for the rest of us, it's good because of the chemistry that you learn about. Now, there are other resources that can be useful just as reference, and of course, if you're taking on a career in safety, this becomes important. So NIOSH is kind of the research arm of OSHA, is what I've always been taught. But actually, they're part of the Centers for Disease Control, whereas OSHA is part of the Department of Labor. So they're really two separate places, but they were both formed by the same act. The OSH Act of 1970 formed both of these entities, these government entities. So NIOSH stands for the National Institute for Occupational Safety and Health, whereas, of course, OSHA, Occupational Safety and Health Administration. So they have different roles, but they are very much tied together at the hip. They have a pocket guide for chemical hazards. Now, one of the best places to go to get that pocket guide is to go and look for the NIOSH Pocket Guide mobile app, because then you can have those resources right on your phone. That said, in our course, I have a free PDF, but it's an older version. That's the only thing that's available as a PDF. So I have the 2007 version, which isn't as out of date as you might think. There's a new version, but the older version is not that much different. Now, another resource is from the ACGIH, their booklet. Well, what does ACGIH stand for? Oh my goodness, it's a big old thing. It stands for the American Conference of Governmental Industrial Hygienists. So, I mean, I never remember most of that. I remember industrial hygiene. Industrial hygienists are the ones that deal with industrial hygiene, and they basically are the cerebral side of occupational safety. You can get a degree in industrial hygiene and become an industrial hygienist. So it's a very highfalutin scientific kind of career. I don't mean they're, as far as, I'm not trying to belittle scientists, but this is more of a practical scientist in that sense. But they definitely have a lot to do with measuring. Sometimes, typically you'll have a few people, just a very few people in a big plant that would actually have degrees in industrial hygiene. And they spend most of their time going around measuring, but they're kind of the top dogs when it comes to occupational safety. Anyway, so their booklet deals with the threshold limit values, the TLVs, for chemical substances and physical agents, and so that's important. And then for biological exposures, they've got the biological exposure indices in that booklet too, the BEIs. Okay, a whole bunch of abbreviations here, and I don't mean to scare you off here. This is just interesting stuff here. Yeah, it's not going to show up on any NCCR tests or MI tests either here, but I do want you to be aware that there's a lot more to safety. And this is why I say sometimes, and maybe I've mentioned it already to you, that the more you learn about occupational safety, the more you learn there is to learn. When I first got started, I thought I knew it all already. And that's how most people start when they get into safety. You discover there's so many more layers to this onion, and you realize you know nothing, or comparably so, compared to what you thought you knew. Okay, so I'm humbled by it myself. Okay, so let's see. Something simpler. Here's the colors of safety. Part of the communication of safety is colors. The blue means you've got an informational message. Green means you have a safety message, nothing that's dangerous, but green signs are supposed to purvey something safe, something about safety. So an eye wash fountain is not a dangerous thing. It's an important safety tool for you to know where it's at in case of the emergency, but it's not a dangerous thing. So we use green for those colors, for that. Yellow means is a caution sign color, and it means you've got something that's somewhat dangerous, but not immediately dangerous to life and health. So things that are important safety messages, but they're not rising to the level of danger or even warnings. And then we've got the red color for danger signs, things that are immediately dangerous to life and health that you must draw attention in red for. Then there's something that's not on the page here for orange, for warning signs, which things that are dangerous to life and health, but the probability is much lower. So so that's where we get the orange traffic bins and signs that are in orange directing traffic and other things like that. So warning signs are in orange. Here's some more things on here. For instance, down at the very bottom, besides these things that I've just mentioned, there's purple, or maybe better said as magenta, which I never knew what that meant until we had printers, but for radiation hazard. And so radiation hazards are typically listed in purple or magenta, and then Sometimes orange has been used for biohazards, but things that are very dangerous biologically are typically also in red. Things that are very, very serious. So it gives me an excuse to show a few crazy signs here as we're going into this. But signage is certainly part of it. So worker responsibilities, you got to learn to recognize the hazardous materials labels. So we'll be talking about them. You have to know where the safety data sheets are kept at your job site. The employer is required to make them available to all employees. So all employees are supposed to know where they're at. So if you don't know where they're at on your job site, you should be asking about them. Now, if you do that on a residential job, you're going to be laughed at probably. So they wouldn't have a process like that. And maybe might not be so necessary. But certainly in the plants or on large construction sites, they are required to, and they should know about this. If they don't, there's something that you're teaching them. Report any hazards you spot on the job site, anything particularly dealing with toxics or that can hurt you either immediately or over the long term. So all kinds of exposure hazards. There's two sides of the coin of safety and health. When we talk about OSHA, occupational safety and health, safety is protecting people from physical harm. Health side is dealing with protecting people from exposure to harmful chemicals, harmful substances, harmful noise. They're all part of it. And you need to know how to protect yourself from these various hazards. And you need to know what to do in an emergency when there's a chemical spill, when there's an exposure, when there's a chemical leak. And so you should understand your employer's HAZCOM or hazardous communication program and what kinds of things you're supposed to do. That's all part of this. So more things about the signs. Well, that's just a brief little part of this, but just showing you some of the colors of safety being used and also some of the categories. So when we talk about hazardous materials, there's radioactive hazards, there's the physical hazards of chemicals, like a flammable substance. That's a physical harm when something can catch fire, then burn you or explode and throw shrapnel. That's a physical harm. So that's about the safety aspect, whereas the health side is dealing with the poisonous nature of chemicals and substances. And also in the short term, as far as acute hazards, things that can kill you today. And then there's the chronic issues about things that are exposures like exposures to asbestos or silica hazards. They tend to cause trouble over time. And so we call them chronic hazards, chronic issues. So, yes, you can have all kinds of hazards with different materials here. For instance, with wood, there's flying particles maybe from saw, and that's a physical hazard. That's not a health hazard. You see the difference here. In X-rays, X-rays are a form of radiation exposure to worry about. And you say, well, I'm not signing up to work on a nuclear job site, so why does this affect me? Well, when we're talking about in the petrochemical industry, and that doesn't mean that's where you're going to work, but if you were going to work there, the welding that they do on pipe has to be perfect because it's typically sealing in a gas or a liquid, and so it's not just to make it strong. Plenty of times in construction for structural steel buildings and for precast concrete members, we weld them together, and we don't care really how pretty the weld is. We want a deep penetration, strong weld. But in pipe, we want it to be perfect because it can't leak. And so they have to X-ray the pipe. And so if they're X-raying, they have to worry about creating a zone of safety around the zone where they are X-raying with these radioactive rays that are part of the X-ray process. You got a very external process here compared to your dentist office. And so you have to zone off those areas and put signs up. So some of these symbols, these are all supposed to be red, but I don't have them in red in this particular case. But red would be the color of danger and certainly physical hazards, and these signs should be red. There's a red sign for combustible, at least anyways. And there are some funny signs just for the fun of it. I took a picture of this roofing trash sign And then it's a good thing I did, I guess, because a day or so later it was gone. I think probably his wife made him take it down. Spelled so badly, Okay. So when we're talking about the chemical hazards, the skull and crossbone are still used very, very effectively for things that are acute hazards that can kill you today, the short-term hazards. So things like H2S, hydrogen sulfide, are very toxic, and they can kill you with a single dose. Or if it's a lighter, very light thing, then maybe it could be a little bit less of a less than life-threatening, but it can still be a serious health hazard to you today. There's other things like asbestos and silica that are dangerous and a health hazard, but just about no asbestos or silica hazard is likely to turn into a serious fatal exposure until you've had months of exposure. I guess if you had an extremely pure source of asbestos or silica and it was just an extreme exposure where you're just freebasing all kinds of dust, I guess there's cases where it could be very serious in a day, but in general, the vast majority of cases, it's working around this stuff day in, day out that gives you the trouble over time. So, asbestos mortality, so it's in these spots. Whoa, you don't want to live there. Well, these are where the cities are, so it's ultimately where we live. So the population of this country is mostly distributed on the north and the east, and there's not a lot in the middle. Yes, there's more as you come to the east, and it gets wide open as you go into the west, but by the time you get to the west coast, it's very populated also. So that's where the asbestos is at, because that's where the asbestos, that's where, the exposures are where the asbestos is at, and so mostly in older homes. It used to be in brake shoes. So if you were sitting at a bus stop back in the day where all the braking was happening, you were probably getting a pretty good dose. They haven't had a lot of asbestos in new products for a while, but I think it's coming back because they've kind of decided there still is nothing better for a fire retardant material for brake shoes, for instance, too. But here's some samples of asbestos that you'll find in older buildings: rock wool and vermiculite insulation, pipe insulation, lots of pipe insulation, and the brake linings in older vehicles. Well, you're not going to see that so much anymore. Plenty of asbestos tile shingles and floor tile and siding made of asbestos. But if it's in a solid form, it's not dangerous. You can touch it. Heck, you can probably eat it. Well, no, I'm joking. No, don't try eating it. Don't try it, please. But it's the breathing in is all the real hazard is, and so that's real enough. But so you want to make sure that you're not around this stuff in a way where it's loose and airborne. In fact, when we're doing an asbestos cleanup, half the battle is getting it wet so that it's not airborne, or containing it inside of containers as you remove it. So sometimes if they had to remove this insulation from just this area of this pipe so they could change this valve, they would wrap it all in a big bunch of plastic to seal it up, and they would, part of wrapping it up is they'd have a spray wand in there, and they would soak it as they were massaging to break it up in the bag and spraying it the whole time to remove to reduce the dust and to get the dust down to nil in the bag as they remove the bag from it. So they would literally do kind of a, seal it up and break it all up and then wash it off and everything while it's all still contained in the bag and remove it. But if it's a whole room, well, then they got to use special air scrubbers, wear special respirators, special suits, tape up and everything, and a whole big production. Okay, well, more information than you probably cared or needed for this about asbestos, but it's a whole career and a whole contract, just special licensing for contractors that deal with asbestos removal. So there's 6 basic kinds of asbestos. There's a tremolite, not as common. It used to be found in talcum powder, so there's been lawsuits on that. The whole thing is if they got straight needle-like fibers microscopically, then it's dangerous. So that's why this is dangerous. As you breathe it in, they're like little darts that land in the tissue of your lungs. Actinolite, not so common either. I don't know what kind of products it was in. Again, it's when it's airborne that you breathe it in. And a lot of this stuff will float with the static charges in the air, and I've seen it in there. And it tends to just float in there and in the middle of air and not drop. anthophylite asbestos, again, not so common. But this next page, again, all straight needle-like fibers. Now, the top one is considered maybe the safest form of asbestos out there, the chrysolite, sometimes nicknamed as white asbestos. This mineral has kind of a serpentine fiber, and so it's not, doesn't have a lot of straight needle-like fibers, so that maybe it's in its safest form. Now, they call it white asbestos, but you know, the stuff that I've seen, this bright white, the stuff that I thought might be a white asbestos was actually amosite asbestos, the middle one, which is nicknamed brown asbestos. So yeah, it looks kind of brownish in this picture, but when I see it in midair and see the stuff on the pipe, it looks very white to me, very white, and it's amosite. So it's very dangerous, or is straight needle life. It's used a lot in cement, backer board sheets back in the day, and in pipe insulation, and it was used on as insulation for fire retardancy also. And the most dangerous form is this crocidolite, and I see the word crocodile in there, but even though it's not really in there, but crocidolite asbestos is called, nicknamed blue asbestos, and it's considered the most dangerous form because the needles are smaller and sharper, even very straight needle-like fibers. And so as you breathe them in, they're going to stay in your lungs, and they're not checking out. Some of the stuff you can get into your lungs of this kind of stuff and other kinds of silica dust and things, and cough up some of it in your phlegm and get rid of it. Some of it maybe you swallow and runs through your system that way, through the tummy. Some of it's going to end up staying in your lungs as sharp needle-like darts that are landed in the dartboard of your lung tissue. And your lungs have to handle this stuff, and what they do is they grow calluses or growths around these fibers, and that part of your lung can no longer absorb oxygen. And so you keep reducing your lung capacity the more of this crap that you breathe in. So it's really important that you take this seriously about breathing asbestos or silica. And remember, silica is the most common mineral across the face of the earth. It's everywhere. It's in the gravel and the sand, and it's in the Portland cement of concrete. And so when you saw cut concrete, you're getting a freebase, pure version of silica. Very dangerous to breathe that stuff, and people breathe it all the time. It's in many forms of drywall. The asbestos is in some of the forms of drywall, and there's silica in drywall. Okay, so here's some silica. You know, I've been talking about asbestos, but here's silica dust in the lungs, on the ugly lungs over on the right-hand side of this page. So it tells you can see this stuff in the lungs in an X-ray. Both the silica and the asbestos shows up. Now, again, focusing on silica instead of asbestos, fracking has made an example where we now get certainly the Portland cement dust, but the fracking is another area where we have trouble with silica dust. You know, when they're drilling for natural gas, they go and they drill deeply, and they put the whole thing under extreme pressure to crack up the shale. Shale eventually becomes slate, given enough time and pressure, but originally it's a shale, a weaker thing. And the shale is a sedimentary rock, and as they break it up, it releases natural gas. And so it's one of the great new industries. Causes earthquakes in some parts, like in Oklahoma and stuff, where we've had some places where they've never had earthquakes before until they started doing a bunch of fracking, and that's fracking with the earth crust, I guess you'd say. But in doing so, they end up with a whole bunch of silica dust that comes up as a liquid, but eventually, if they're not careful, you've got this liquid spilled out all over the job site, and as it dries, you've got this chalky white dust everywhere from the silica dust, and it's blowing around, and people are breathing a very pure form of silica. So there's another area. So different exposures have different results. I've been using these terms, but here they are written down. So a short-term, brief, intense contact to something that is dangerous in short-term contact is called an acute exposure to an acute hazard. So hazards that are dangerous in short contact are called acute hazards, And of course, an acute exposure is a short-term exposure. So we worry about that not with asbestos and silica generally. We worry about acute exposures to chemicals like phosgene gas, which is extremely deadly, or H2S, which is quite deadly. And there's plenty of other poisonous gases out there. Then there's the long-term hazards about things like asbestos and silica, which takes a low-level contact over much time, so months or years, and next thing you know, you've got a cancer or a silicosis or mesothelioma or something. So chronic issues, chronic hazards, when you've got chronic exposure over much time, then that becomes an issue. So it's important to know the difference. Acute is short-term, and if you think about a cute little bug or a cute little kid, they're short. They're small. So we're talking about a very small amount of time, and if something is dangerous for an acute exposure, it makes it very dangerous. Whereas chronic exposures to chronic hazards, we're talking about long-term exposures. And we've talked about the PPE that you need to use to protect yourself, because a lot of these exposures, it's about protecting yourself from breathing the stuff in. There's some chemicals that are dangerous to have exposed on your skin. Some, even your eyes, can be bothered by it. So you might need to have the full face mask in order to protect your eyes from an acute exposure. The chronic issues are mostly about breathing it in, mostly. So that's not a respirator. We saw that before. Now we're going to the labeling. With labeling, first of all, on a construction site, all materials all dangerous substances and chemicals, such, we call them materials in general, must have labels on the cans. There's only one kind of special exception, and that's if you're the only one in the world left. Well, no, not quite. If you're the only one on the job site, so nobody else could possibly confuse what's in your mystery container, and you know what's in there. So that's one special exception that I probably should not even have mentioned, but I did. Okay, so there it is. But so this is one of the labeling systems we have, is the NFPA 704 system. Does that sound a little familiar? Well, we talked about it in the fire protection and prevention chapter. So here it is again, that NFPA 704 hazard diamond, where 0 is when you got these numbers from 0 to 4 and the three upper diamonds, where 0 has no hazard and 4 is the highest form of hazard. And so the top box, you've got flammability hazards in red, the left box is health hazard in blue, and the right diamond has instability hazards in yellow. And then the bottom box is for things that don't fit in any of those categories. But this is all about acute hazards, short-term hazards, things that can kill you today, in this moment, in this afternoon or this evening, whatever. So out of that, yes, I talked about it before, so I'll leave that alone. Other than just to remind you that when we're talking about the flammability, the fire hazard at the top in red, it's all about the flash point. So the lower the temperature, that the flash point temperature is at room temperature or less, basically 73 degrees or less, then we're talking about something that's extremely dangerous, compared to number 1, where you've got to heat it up to 200 degrees before it's dangerous. So that makes it a more stable substance. Okay, so moving along, the Department of Transportation has hazardous materials labels that go on the back of trucks, and that's where you'll see them. You'll see them also labeled on containers and tanks and 45-gallon drums and that sort of thing too. And so a lot of this stuff shows up in the shipping and the transportation of hazardous waste or hazardous substances that aren't really considered waste, but products. And they're, for instance, maybe in a tunnel, you might not be allowed to ship that. You might have to take the long way around with the truck with that. And these are things that truckers have to pay attention to, and they have special maps to help them and special apps to help them, guide them as they travel across the country with this stuff. Well, the United States, along with some other countries like Canada, the European Union, China, Australia, and Japan initially, and then a whole bunch of other countries have joined in since, implemented a standardized system across the globe called the Globally Harmonized System, or the GHS. And this involves standardizing a new kind of a label, and it's standardized to work everywhere. And standardizing the standard safety data sheet, what we used to call a material safety data sheet, we now call a safety data sheet. We just dropped the M, or the materials. It's understood that we're talking about materials. Safety data sheets refer to dangerous materials. Okay. And so they phased in really starting in 2015, and it took a few years. So maybe by 2017, pretty much everything was phased in. So we've been using them for a while now. But anyway, so I'm kind of, this part of the presentation was something that I created when they were first phasing it in. So there's some of the things reference those dates. But ultimately, there's the new label right there. Now this is generic because there's actually no chemical really listed here. They're just listing stuff. But generally, these labels have pictograms on them. They can have 1 or 2 or 5 pictograms that represent certain safety issues. Then they can have a signal word. There's only 2 possibilities, and then you see that's blue. It's underneath the pictograms, the red diamonds. You see the word signal word. Well, it'll say danger or caution, one of the 2. And then they can have hazard statements. So for instance, here they've got highly flammable liquid and vapor, and then the next line underneath that says may cause liver and kidney damage. Well, those 2 statements are very different from the kind of, or one of those statements is very different from the kind that you would have or be even focusing at with that NFPA 704 hazard diamond. The hazard diamond only deals with acute issues, whereas this label deals with acute issues and chronic issues. So it deals with both. And they can have precautionary statements and such. So we'll come along here a little bit and just kind of move to talking about the actual label. So let me kind of get to one. Well, this is that same label blown up. I forgot I had it that way, but let's move on to find something else here I wanted to bring up, and that would be just an actual sample of a real label. So hydrogen sulfide is a very dangerous chemical. It's very toxic. Its chemical name is H2S. So you see up at the very left-hand corner, I've got it listed as H2S is the label. So H2S is the chemical code name for hydrogen sulfide. And you see there's 4 pictograms in here. They've got the skull and crossbones. That's for things that are an acute poison, something that can kill you right now. And they kind of put them in the order of importance. So the first thing on the left is the most important, that it's toxic. It is also flammable, so they have a flammable label there too, and a flammable pictogram. Typically it comes under pressure, and most of the time it's stored under pressure, and so if it's leaking out, it's leaking from a tank or from a pipe that's under pressure. So that tank is there. And then something that's not required by OSHA, but is required by the EPA and the Department of Transportation, is that thing about the fish swimming upside down. Fish, when they're swimming upside down, they're not usually doing too well, dying or already dead. And so the idea is that there's an environmental hazard with H2S also. And then they have the word danger up there for a signal word. They have some precautionary statements underneath that. And then they have some various other precautions. And then what's really important is you've got first aid information about what you should do and shouldn't do. So they do mention rinse cautiously with water for several minutes, remove contact lenses if present and easy to do. Continue rinsing if eye irritation persists, get medical attention. If inhaled, okay, that's if it's in the eyes. If inhaled, remove victim to fresh air and keep at rest in a position comfortable for breathing. Immediately call the poison center, doctor, or physician. Specific treatment is urgent. If it's urgent, then maintain them in a adequate ventilation. You consider administration of 100% oxygen, which can be a little dangerous. You got to be well ventilated. Sodium nitrate may be used as a useful antidote, so that would require a doctor. Anyway, so the point is there's critical information on this page, and it's all about the emergency stuff we need to know, and that's what makes this label. So this label is called a HAZCOM 2012 label. So HAZCOM 2012 label. Remember, the other label was called the NFPA 704 hazard diamond, maybe my best description of it, that diamond thing. This thing has a bunch of little diamonds all on it, but that's not, the same thing at all here. This thing is useful for more than just acute issues. It's useful for chronic issues too, because it will deal with things that are long-term, if there are any. And here it seems like everything is short-term pretty much. So there's 9 possible pictograms that can be on that label. So here's all 9 of them here, and that might be the most efficient way to look at them. The health hazard of the top here deals with things that are long-term hazards, carcinogens, mutagenicity. Okay, that's hard for me to say. Various things that are long-term. Whereas at the opposite corner, bottom, that was at the upper left, down at the bottom right, we've got the skull and crossbones, and that's the opposite in that it's still a health hazard, but it's an acute toxicity, something that can immediately kill you. So that they are quite different in that respect because of that. But they both deal with health hazards in that sense. This flame up at the top, dealing with flammables, but meanwhile there's another flame down at the bottom left that deals with called flame over circle, and that's for things that are oxidizers. Oxidizers tend to react wildly to water and to and they take on a life of their own. They react with things. They produce their own heat, so they're particularly dangerous. So you got the O with a flame on it, the O for oxidizers. There's the exclamation mark for things that don't fit neatly in any other category, like, for instance, there's narcotic effects or skin irritant, skin sensitizer, hazardous to the ozone. Well, then that's not a issue for safety so much as it is for environmental rules. There's a gas cylinder we already talked about. If something is corrosive, then hard on the skin, hard on the eyes, corrosive to metals. Well, that's for that center one in the center of this group. If it's something that can explode, if it can be explosive or very highly reactive, then they could have the exploding bomb symbol. So these are all in here, and I went through them one after the other, but I think in the interest of time, I want to kind of go past that. I do like this organization. It's the same, all the same symbols here, except that they're grouping them with some are dealing with physical hazards and some are dealing with health hazards. So I thought that was an interesting way to describe that too. So beyond that, you do need to know these, not for tests, but in the industry you do. I haven't added these as test questions. Maybe I should, but I haven't. So what I do want to get to is to compare the 2 labels. Well, particularly the 2 that we've been working with, the NFPA 704 hazard diamond and the HAZCOM 2012 label. So the big difference is, okay, the NFPA 704 has those 4 little diamonds, but it has 3 of them where they have numbers between 0 and 4. We talked about that before, where 0 is the least dangerous and 4 is the most hazardous, whereas the HAZCOM 2012 label can have one number between 1 and 4, no 0, but it goes the other way. The 1 is the most hazardous and the 4 is the least hazardous. So that's kind of crazy. Now, they are 2 separate labels, but it is kind of strange. And see, why would we do that? It's because we had to make this compromise because most of the rest of the world looks at things. If they're the most dangerous, it should be number 1. And if it's less than that, then it's a lower, and then you go further down the list of numbers. And so it's just a different way of looking at things. And so we've had to make that concession. That said, I think what will probably happen with the NFPA 704 system is it'll have to be revised at some point, because it's not good to have 2 systems like this dealing with the same issue where the numbers could get mixed up. It's a safety issue. So they might start using letters A, B, C, D or something, maybe. I don't know. Just a suggestion. National Fire Protection Association. Okay, so beyond that, I want you to know that factoid for a test question near you. Some of the things in here I'm going to skip. I'm going to go skip to another one. And then the other thing I've already mentioned also here is that the NFPA 704 system only deals with acute short-term health hazards only, whereas the HAZCOM deals with both the acute and the chronic. So those are the 2 main things I want you to know about these things. Now, I'm going to skip along past this stuff and skip along further along and try to be brief. Remember, we talked about the safety data sheet, and that's where we kind of have to finish off. The safety data sheets must be stored in a binder that everyone can recognize and find, or there's a new modern equivalent, and that's to have a special terminal or tablet that's mounted to the wall somewhere like these data sheets would be, where you can go to the terminal and look up stuff. So that's fine. The beauty of having the terminal is you can do a lookup. You can have you can have an update sent wirelessly to it without having to go and trying to keep these binders straight. What if a page gets torn out or lost out of there? When you got a digital form, you can manage that stuff better because sometimes there's new things to update with. So there's officially, in a new official format, there are 16 defined sections of the safety data sheet, and that's what you need to know for test questions. Is there's a few, 3 or 4 of these sections that you need to be able to know well enough to pick out to pick them out for multiple choice test questions here. So let me skip along a little bit more to, here we are, the section. So section 1 deals with product identification. That I should actually put some asterisks in here, and I should have one here for section 1. You should know that section 1 deals with product identification. Identification includes the product identifier, the manufacturer, distributor's name, address, and phone number, emergency contact information, and recommended use and restrictions on use. So just some very basic product information. Section 2 deals with hazard identification, including all the hazards regarding the chemical, including the hazard numbers from the HAZCOM 2012 label, the new label, from 1 to 4, where 1 is the most dangerous and 4 is the least dangerous. So that shows up here in Section 2. Section 3 will give you chemical composition on the ingredients. And of course, the companies that produce this stuff, they hate this section because it gives away some trade secret information. Section 4, so far the one I need you to remember is Section 1, product identification. Then on the next page we've got Section 4, you need to know that one, dealing with first aid measures, because in an emergency, if you need to know detailed first aid measures, it's good to remember it's going to be in Section 4. So Section 4 is first aid measures. Section 5 deals with firefighting measures. Section 6 deals with accidental release measures and lists emergency procedures and equipment. Section 7 deals with handling and storage precautions and handling and storage and incompatibilities, maybe where something that you shouldn't store it next to and that sort of thing. Okay, so far you've had 2 sections to remember, Section 1 and Section 4, and then now Section 8. You need to know that one. It deals with exposure controls, personal protective equipment, OSHA's permissible exposure limits, threshold limit values. That was the TLVs I was talking about at the beginning, the appropriate engineering controls, and ultimately the personal protective equipment that you're going to wear while you're using this material. So this is where you go to find out. Section 8 is where you go to find out about the PPE that you need to use in order to work with it. Not talking about the cleanup or a spill, just to work with it. Okay, so that's Section 1, Section 4, and Section 8. Now, you also need to know Section 9. 9, 10, and 11 correspond to the 3 diamonds on the NFPA 704 hazard diamonds. So Section 9 deals with the physical and chemical properties of the chemical's characteristics, and it corresponds to the top diamond on that hazard diamond. The red one that deals with flammability. Numbers from 0 to 4 can show up here, where 4 is the most dangerous. Number 10 deals with stability and reactivity. That's the yellow section on the right-hand side of that diamond with numbers from 0 to 4. But the one that you need to know the most for a test, hint, hint, would be Section 9. But it is useful to know that Section 9, 10, and 11 deal with these 3 little diamonds on that NFPA 704 label, diamond. And so section 11 deals with the blue section, dealing with health hazard, And so there you go. And now the rest of this stuff, section 12, 13, 14, and 15, are not required by OSHA, so we're kind of ignoring them, but they deal with ecological information, disposal, transportation, regulatory information that the Department of Transportation for shipping this material and the Environmental Protection Agency for disposal of the material require to be on there. And so I leave it alone here, but those are other sections. And then the last section gives other general information and revision information and that sort of thing. Anyway, so the most important stuff is in the first 11 sections. And as you know, it's basically section 1, 4, 8, and 9 that you need to know those ones well enough to be able to answer test questions on it. And you'll see some of those questions in the quiz for this section. Okay. So I can kind of skip along again, but make sure the employers must ensure that the SDSs are readily accessible to employees. That's another critical thing to remember as a test question. It's one of the easiest ways. An OSHA inspector, you got nothing better to do if you look for the greenest looking guy on the job and say, "Hey, buddy, where do you guys keep the SDSs?" "I don't know." Oops, wrong answer. Now the company's in trouble. Everybody is supposed to know that on day one. So the basic training has to produce this information. So each product used on a construction site, every hazardous material of any kind, including pressure-treated lumber, for instance, must have a safety data sheet. Now I've got in this place, I haven't gotten rid of it, but it used to be called an MSDS for a material safety data sheet. And it took me a little while. I had to cover my mouth and say, material safety data sheet. So I've had it in here and it's time to get rid of it. And I just keep forgetting. Anyways. The next point, a safety data sheet, or an SDS, describes the substance, the hazards, the safe handling, first aid, and emergency spill procedures. All safety data sheets or SDSs must be kept on site and made available to all workers at any time they want to look at them. Anytime. So, let's see. The emergency response teams must use the right personal protective equipment, of course. So rule number 1, don't make the problem worse. So if you got a substance, you look on the sheet and you got to check to see if spraying water on the fire will make it worse. Sometimes it does. Okay, so now we're talking about a couple of pages of summary here, and these are all in the safety data sheet. And I think for the interest of time here, rather than extend this thing off too long, but you can go and look at these things yourself in there, and you can find all of this stuff in the study guides. And remember that for all the study guides that I have, little bitty study guides, one for each little subtopic in this course, every week or every group, I've got them collected together for the study guide for exam 1 or the study guide for week 1. It depends on which kind of course you're in. But there is a printer-friendly version at the end here. So watch for this major study guide that's got all the other little study guides collected in there together. Okay, so beyond that, it's basically the things that I've talked about here. And so at this point, I think we can call it a day on this topic too.